So we're going to be talking about types and identifiers. So what is an identifier? An identifier is what we call a variable, parameter, constant, user-defined method, or a user-defined class. For example, in Java, an identifier is a sequence of letters, digits, and underscores. Most of the time, an identifier will be in lowercase letters, with an uppercase letter being used to separate identifiers into multiple words. So built-in types. All identifiers in Java have a type associated with it. For examples, int is integer or boolean is for boolean. Integers are stored exactly, and when you try to store a value too large for an integer variable, you will receive an overflow error. Identifiers must be introduced into Java with a declaration. The declaration will specify the type of the identifier. So storage of numbers. So integer values must be stored exactly. One of the bits will say 0 for positive or 1 for negative. This is the largest possible byte in Java, the array of numbers shown below. So this example utilizes 1 byte or 8 bits of storage. The integer is 2 power 7 minus 1. The type integer or int utilizes 4 bytes or 32 bits. The maximum value that this can hold is about 2 power 31 minus 1. There are two built-in types in Java that store real numbers: float, which is 4 bytes, and double, which is 8 bytes. So a floating point number is stored in the mantissa, which specifies the digits of the number, and then we have the exponent. When floating point numbers are converted to binary, they can't be represented exactly, which leads to something called a round-off error. Two situations you need to be aware of within floating point operations is, number one, when an operation gives you an undefined result, Java will give you NaN, or not a number. Number two situation is an operation with an infinite number will give you infinity or negative infinity. So hexadecimal and octal numbers. So a hexadecimal or a hex number uses the base 16 and uses symbols 0 through 9 and A through F. A is 10, F is 15. So to denote the hex number, the prefix 0x or 0 uppercase x is utilized. The pro of a hex number is the compactness and the ease of conversion between hex and binary numbers. For example, the example is shown right here. Octal numbers use base 8 with symbols 0 through 7. So the representation would likely be with the subscript 132 subscript OCT. Expanded, it would become the example shown on the very bottom. So now we're going to be talking about final variables. So final variables or user-defined constants are identified by the keyword final and are utilized for quantities whose numbers will not change. Constant identifiers will often be capitalized. Final variables will be declared without initializing it immediately. And a common use for this constant is an array bound. For example, what we have here, final int max students equals 25, and then thing on the bottom. And then using these constants will make revising code much easier. Just one change in the final declaration rather than changing every occurrence of the value. And that's it for this part.